Hey, it's Alex Williams of the New Stack. Hey, we spent a week at Intel Developer Forum in San Francisco recording podcasts about scaled-out architectures in a multi-cloud world. Thanks to Intel for having us a part of the show and the chance to explore more deeply topics such as telemetry, orchestration, and the new dimensions that come as software and hardware more deeply integrate in a scaled-out world. You can learn more about Intel at intel.com. Hey, it's Alex Williams of the New Stack here at the Intel Developer Forum in the Chip Chat booth with Dave Cohen. Hey, Dave, how are you?
How's it going, Alex? I'm doing great.
Great. So, Dave, we were just chatting a little bit before we got started. You work in the SCI group. Tell us a little bit about what your role is.
So my focus is on software-defined storage, and especially how that interacts with the network and physical storage infrastructure in the data center, especially at scale.
So, lots going on right now, in how we think of actually like technology stacks. And in our discussions, we started about 2 years ago, and the story was about containers, but it wasn't really about orchestration because there wasn't really that much being explored quite yet. Now we're starting to see companies like Iron.io starting to use, they're almost like industrial container users. We're starting to see lots of different use cases emerge, and storage being far more effective than ever before. What are some of the observations that you have about the market now?
So historically, storage started out at a really, in the appliances, like an traditional EMC storage array or a NetApp filer. And over time, the cloud and the CSPs, cloud service providers, have really impacted the way people design storage. Mm-hmm. But one of the things that has not really happened, and it's starting to happen now, is thinning out of the storage stack. So kind of removing a lot of the layers, a lot of the legacy file system notions of directories and hierarchies to make it flatter.
What are some of the things that are getting thinned out?
So if you think of a traditional hypervisor type deployment, I have a virtual block device that gets attached to a VM, and the VM then formats that with a file system. But in reality, that virtual block device is actually a file that sits in yet another file system. And so I have all these layers in the data path that, if you flatten those out, you can get much better response times, simpler infrastructure, et cetera.
So they've been layered. Tell us about kind of the developments that have gone into flattening it out.
So when you look at the cloud service provider architecture, they have a very lightweight distributed object store at the back end. Think of the Google file system as an example. And on top of that, they layer a key value store. Google would be Bigtable. Microsoft has something similar. Facebook, they use Hadoop, and so they use HDFS with HBase over top of it.
Okay. So one of the questions that leads to is like, when they're flat, how does that change the behavior of the storage itself?
So the reality of storage today is it's a software workload, and really storage as a data container, the data containers, what you might call a file system or a LUN, that data container is actually decoupled from the physical storage. It might be in cache and memory at one point in time, and then later it's erasure coded on the object storage backend.
Right. So it's a software really workload. And so being at a software-defined workload, the issues changed a lot, don't they? Like what are the management issues that you're working on right now compared to VMs?
So with the emergence of containers as a really popular computational model, the expectation is that you can run anywhere, anytime, and light up a container very quickly and then tear it down just as quickly. And so rather than having, physical servers or later VMs that run for long periods of time in kind of a static deployment. Now I have a very, very dynamic deployment model where I need to be able to load my executables, my packages, and have access to my data in a very fluid, very fast manner. And that really, really changes the way that you think about provisioning and deprovisioning, state management, and all of those things.
So tell us about some of the things that you're working on when you think about this fluidity, some of the challenges that you're facing.
So the number one thing is really having a network that spans the range of how far your deployment goes. So if you think of the cloud, you might want that deployment range to be your entire data center. So I should be able to light containers up anywhere, anytime across that entire data center. But in order to do that, I need a network with enough bandwidth so that the network's not in the way. And that's step number one. Step number two is to treat the network and the state management problem first and foremost as a content distribution network, so that I put caching into the network itself, much like how the internet works today.
So working at the edge, really.
Right.
I haven't really thought of it as a content distribution network.
So Docker packages, jar files, etc., are all binaries, not unlike YouTube video files. And so, pushing those to the edge so that the requests can be serviced locally makes a huge difference.
I never heard of them as like YouTube video files, and I guess a YouTube video file is a process, right? Isn't it?
It's just a binary
data in a container, right?
Well, when it gets loaded into the process that's rendering.
Right. So the content itself.
So when I load an image into Docker to run it, it's being loaded out of a cache somewhere.
Right. So does that create new requirements for those content networks?
Well, if you
those content,
it really imposes a different requirement in the data center network. You want your racks or somewhere close to your rack to be able to have caches to hold this content, so that you can service it there rather than going back to central storage or the objects.
We've had caches for a long time.
For a long time, yeah. Yep. This is just using them in a different way.
The caches, do they need retooling?
Well, you might think of, if you use Redis as an example, I might want to...
Caching platforms, I guess, more is...
you might want to have new protocols besides just HTTP.
Right.
So MySQL or whatever protocol, REST or whatever the Docker's using, JSON, you want the load balancers and the caches to be smart about those protocols.
Right. Whether to be smart about those protocols. What do you mean by that?
Well, so in HTTP, it's a beautiful thing to be able to distinguish between reads and writes by knowing gets versus puts.
Right.
As an example, reads can be cached aggressively, and if I can recognize that a request coming in is requesting data that I've already seen before, it's pretty straightforward.
Right. So now we're starting to see containers being used for all different kinds of purposes, but the data behaviors don't change that much, do they? Like if I'm in a browser, right, the cache is letting me, autofilling, for example, my search query, right?
Right, but if you're running, let's say, a MySQL instance that's part of a MySQL cluster, and I'm scaling that elastically, so maybe it's got 3 nodes, then it's got 20 nodes. Each one of those MySQL instances is running, using RocksDB to access its state. As an example, you're scaling that out pretty widely and then shrinking it back in, and those nodes are coming and going pretty quickly. So having that state cached, understanding where it's cached, becomes an interesting orchestration problem.
So it becomes an orchestration issue. So what are some of the projects that are being developed right now in the open source community that relate to this?
So some of the things that are going on are things in the load balancing space.
Right.
So, all the traffic is IP-based. It's pretty straightforward to see how you could use an SDN controller-like model for higher level storage protocols with a small amount of intelligence in the load balancing scheme. As a request comes in, if I haven't seen this before, I can go ask the controller, where should I actually service this request from? That's a reasonable type of implementation. MySQL has a router that's used in that way. There's a load balancer for Redis. There's a load balancer for MongoDB. All of these things are, leading to this control plane, data plane type of.
Right. But the control plane's changing so much, isn't it? I mean, the idea of a control plane, it's far more, we used to think of like control planes that were not distributed. Now we're seeing far more distributed control planes.
Exactly. So in storage, storage is very stateful, so it's not like routing in the context of BGP as an example. So you have some degree of state management, so that part of it is like, I've got an inventory of all my quote-unquote volumes or buckets or whatever. I need to at least have a name of a bucket and an idea of where I can find the master bucket and maybe its replicas. And so that directory system serves as kind of the top-level control.
Okay. Yeah, that gets very complicated, doesn't it, very quickly. When you're thinking about persistence in the storage, right? What are some of the kind of the new challenges you're seeing now with these distributed environments with the software itself? I mean, the software itself can often be, running on different installations in different places, right? The actual, the syncing of all that has to be challenging.
So the interesting thing is that, for a given service, it's easy to think of S3 as an example at Amazon.
Right.
When you provision a bucket, your bucket's given a name, and then it's effectively a key value store. And it's simply a set of entries for metadata, and then some references, URL references to objects that you've uploaded into that bucket.
Okay.
An EBS block device isn't much different. A SQL database from Aurora is actually very similar as well. And so you have this need for metadata about the resources that you're provisioning virtually. In each case, I can model that as a table, partition the table into small key value stores, and then distribute those broadly across my data centers.
So it's the continued granularity.
Right, so you get lots of parallelism, lots of scalability. You can reason about this through some kind of naming convention or hashing, and it scales very, very well.
So is it the parallelism then? That's what it is?
Well, the parallelism means that I have thousands of servers,
right?
And so my service can run broadly across all of those servers.
Right.
But in order to reason about that, I want to think of it as a partition key space or partition table, where I'm mapping partitions onto different servers across the data center.
Seems very interesting new territory for a hardware company.
Well, it's a very, very common paradigm, and so as a hardware company, especially one that's bringing non-volatile memory to market, et cetera, we want to make sure that our platform is the best platform for running these workloads.
Right. And there's something unique about the container itself and how close. I mean, the best way to what's the best way to monitor a container in your?
Well, in what I'm describing now, it's monitoring. A lot of it is monitoring memory bandwidth,
right,
as well as I/O bandwidth.
But it's very much the chip level kind of stuff.
Yeah, I mean, you want to be close to the metal to be able to associate the load that's being generated against the partitions and the data service that's driving that load.
So what parallels do you find, to virtualization that you're seeing with container technologies in terms of this development?
So it's, there's parallels, but a lot of this is different too, in that I see more, actually, I was talking to somebody the other day, I see more parallels with like old school MQ series on the mainframe with containers than I do with virtual machines. Well, in a queue model, basically I get an entry posted to the queue and a thread wakes up and processes it. MQ series, you used to be able to do that transactionally. With containers, it's kind of the same thing. If I think of Lambda, I can get a data event. It basically acts like a queue event. I wake up a function. Ideally, that could be treated transactionally and process it. And thinking about inputs to a function and outputs is much, much simpler than having to deal with a full-blown virtual machine.
That's very interesting. What are you going to be focusing on over the next 6 months? Like, what are some of the things that you're looking at?
So right now we're seeing a disaggregation of devices from compute. So for a long time now, people have been using direct attached devices on the compute nodes, but with increasing capacity and just the raw performance of non-volatile memory express, NVMe, there's a really compelling motivation to share those devices over the network so that you can get better utilization of the resource. And so NVMe over Fabrics just got finished through the standards bodies. We see a huge amount of presence here at IDF this week, showing off kind of how that's going to get utilized. What it allows you to do is take an NVMe device with huge amounts of random access performance, throughput, and increasing amounts of capacity, and partition that up so that it can be accessed in parallel by a bunch of different containers or virtual machines.
I'll have to go walk around and kind of look for insights into this more. So thank you very much, Dave, for taking some time to talk.
Thanks for having me, Alex.
Appreciate it. We spent a week at Intel Developer Forum in San Francisco recording podcasts about scaled-out architectures in a multi-cloud world. Thanks to Intel for having us a part of the show and the chance to explore more deeply topics such as telemetry, orchestration, and the new dimensions that come as software and hardware more deeply integrate in a scaled-out world. You can learn more about Intel at intel.com.